Hello, I'm Rebecca the Maths Lady, and this video is all about teaching maths with a 10 by 10 poppet. Now this video is designed to work for you if you're a full class teacher, if you're working with an intervention group in schools, if you're a tutor, or if you're a parent. And we're going to go right through from easy math up to maths for children who are aged about 11 years old. Now, of course, you may be much more interested in one level of maths than another, so to help you navigate this video, there's going to be clear titles that you can scroll forward to and find the section you're looking for. So the sections are teaching early maths, that's learning to count and very early addition and subtraction, working to build fluency on the numbers to 20, working with the number square, that's the square where you have your numbers to 100 on it like this. Working with base 10, that's doing calculations like 23, add 46 and so on. Building understanding of and developing fluency with multiplication tables up to 10 times 10. And then developing a deep understanding of and the ability to do division at the same level. We will look at factors and factor pairs for numbers. We'll talk about prime numbers, square numbers, triangular numbers, and then we'll do some work on shape and how we can teach shape with this poppet, and on symmetry, and a little bit of work on data. And finally, I'll talk a little bit about classroom management when you're teaching with a whole class of students who are using these. But before I start on the maths, I must just point out that this is a fabulous relaxation tool. I use it a lot when I'm leading into a brain break or kids are tired and they're going to get some de-stress time with this, just to play with it, do whatever they want with it, pop it. This is not a fad that's going out of fashion. Children just love these, even though they're past their peak in popularity. And they really enjoy the chance just to take a moment out and de-stress. So please don't ever forget that this apparatus has that capacity built in, because it is such a joy and such a strength of working with poppets. Right, let's get started with some early maths. So the first thing that we want children to be able to do is to correspondence count. If you say a number up to 10, if we say 7, they should be able to pop 1, 2, 3, 4, 5, 6, 7. And can you hear there that I counted as I popped and I stopped at the right time? Now that's an incredibly important thing to check that children can do. Because if you've got a child even at much higher level who's really struggling with maths, it may be that they've got problems even at this level. And you need to focus in on that skill and work with it. And if your child is not making rapid progress and does not have a medical diagnosis that explains that, then you should be asking for an assessment, possibly for a condition like dyspraxia. If the children you're working with are under 7, there's a good chance that you can address these issues with good maths teaching and some physical exercises, such as those in the Maze of Learning book here, that are going to help children's coordination, and here's a link to a video that explains that in more detail. Then of course we can start children on easy additions. So if we have an addition like 5 add 3, we can help children understand that they need to pop 5 and then pop 3, and they need to count the total, and that there are shortcuts for doing that. They may choose to count 1, 2, 3, 4, 5, 6, 7, 8, or they may choose to count on from one of the numbers. We know we have 5, 6, 7, 8, and that leads on to knowing that it's wiser to count on from the larger number of the numbers you're adding. And if you need an extension activity for the children who are flying with that, they can add more than 2 numbers. And then for subtraction, if we looked at a calculation like 8 subtract 3, we'd want to pop the 8. This time the 8 is the total. There it is, and we can beautifully see that structure that 8 add 2 is 10. So 8 is 2 less than 10, but that's an aside just now. We need to start with our 8, pop back our 3 that we are subtracting, and count what's left. And there's the 5. Or we can count down from the 8. We start with 8, 7, 6, 5 as we subtract the 3. The next stage of early maths is to work on partitioning the numbers to 10. So if I gave children a number like 8, how could they partition that into 2 parts? And this 10 by 10 poppet with bars of 20 really help because we can show the 7 and the 1 in one section. We can show the 6 and the 2 in another. We can show the 5 and the 3 in another, and the 4 and the 4. And then we can have a discussion about whether 3 and 5 is different to 5 and 3. But essentially you've got these structures here. You can see the beautiful patterns. You can encourage children to think about working systematically. And for children who are flying, you can say, well, how many ways are there of partitioning 8 into more than 2 numbers? That should keep them busy for a while. So then we move on to our work on building fluency with numbers to 20. And that's where I think this 10 by 10 poppet has not yet evolved to the state that it's going to reach when it's really ready for math classrooms. And I've been talking to some suppliers about this. We need a 10 by 10 poppet. Ideally, for me, it would be split into quarters of 25, blue, red, red, blue, or whichever 2 colours you're choosing to use. But in reality, looking at the way these are manufactured, I think we're going to end up with something like this. And I know that when suppliers get their heads around how good these are for maths teaching, these are going to appear and become really good value. But they need to look like this because we want children to see the structure of the numbers to 20 in 5s and extras. So for example, for them to be able to instantly see that that's 16. We want to be able to teach them to recognise that structure just as it exists with your fingers and your toes and with tallies and in 10 frames. And on this bit of apparatus, once the 10 frame is set up like this, it will have all the benefits of the Rec and Rec. That is this bit of apparatus. These are both Rec and Recs, as well as all the features it currently has. And when it's set up like that, you'll be able to do all the activities I've described for numbers to 20 in this video. But I'm not going to focus on that yet because we don't yet have this structure. So our work with that is limited just for now, but hopefully that will be coming soon. Now, the next bit of this video is about teaching the number square. I have a whole video about teaching this particular bit of maths to young children and how beneficial it is. And in it, I talk about how we teach children to memorise their number square. It doesn't necessarily have to have 1 in this corner, but you need to be consistent because ultimately you want children to have this internalised in their head so they can see it even when it's not there. And we talk about using that for building fluency with the 2, 5 and 10 times tables because they can see the patterns. And in that video, I talk about how we get children to take a mental photograph and then shut their eyes and see this in their imagination. And of course, we can use this to help. They can, in their imagination, project the numbers they've just seen on there into here. Can they now press the number that you say, that single number? And you can check if they can see those patterns. Can they see the patterns of the 2, 5 and 10 times table? Well, the 5 times table, for example, looks like that. And they should be able to count the 5 times table thinking with this structure. And it's great for children who are about 7 years old to be able to move from that to that. You can really see what they do and don't understand. Right, our next topic is introducing 2-digit numbers with a base 10 structure. So we're moving away from, say, 49 being a single pop, which would be this one, to it being 49 pops. Do children properly understand what 49 is? Can they do 49 pops? Can you imagine how exciting that's going to be with a class of children who are at the right age for that challenge, and how they can see what each other is doing and help each other out and be in competition and just have fun and have all the benefits of this being a game. Now, quick reminder, if you're doing work at this level, I strongly recommend using arrow cards to represent your numbers at least some of the time, so they can really see that that 49 is 40 and 9, 4 10s and the 9. Now, once they can represent a number, let's take the number 23. First of all, we want them to be able to think 1 more and 1 less, 2 more, 2 less. What is that number? And then we want to represent those sentences with calculations. So it'd be 23 add 1, 23 subtract 1, show me with your poppets. And then we want to go on to adding and subtracting a single digit number to or from a 2-digit number. So an essential skill that a lot of people fly past, but children learn so much. So 23 add 8, we want them to see that that 8 is going on as a 7, which takes us to 30 and a 1. And similarly, if we'd been subtracting 8 from 23, we would have wanted them to know that they are subtracting 3 to get back to 20, and then subtracting another 5 to get down to 15. Now that's a difficult skill, but it's the skill that allows children to become fluent with their partitioning of small numbers. It practices it, and if you really work hard on it with your class, children do get the hang of it around the age of 7. And then when they're working on more complicated calculations, they're not going to be counting on and back one at a time. They're going to be able to use the shortcuts that come from being taught this particular skill. It's an essential skill. I usually teach it with the counting beads, and here's a video which goes into that particular skill in more depth. But with a lot of the schools I've been working with, teaching teachers to focus on that skill has made such a difference to the children who are struggling, because the children who are flying just get it. But often no one's aware of what it is they get. And then around the age of 7 or 8, as you move on to more complex calculations, classes split into those who are flying ahead and those who appear to be wading through mud and going backwards. And it is because these children are forgetting their partitions of small numbers because they're not using them. Whereas these children are using them without thinking about it. And therefore they're always practicing them and they're getting better and better at it. Okay, multiplication tables. Clearly for multiplications up to 10, we just use array with the poppets. So if we're doing a calculation like 6 times 5, it's just a case of popping out a rectangle that is 6 long and 5 high, or the other way round, it doesn't particularly matter. There it is, and then counting them up. And hopefully children can see a shortcut that 2 5s are 10, 20, 30. They can see that. And they can use this for any multiplication. And if it has this structure, it's going to be much easier for them to see the shortcuts for counting up their totals. And as they think about those shortcuts, obviously they're learning a great deal about the connections in maths and the distributive law and so on. Tables are a particular reason why I'd love to see a poppet that was in quarters in its coloration, because then you can so clearly see that 5 times 5 is 25, which is a quarter of 100, and then you can see facts that relate to that and develop from that and see all sorts of patterns and structures. But in the meantime, I'd just be delighted to see some poppets that were structured like this for maths classrooms. Available cheaply, please, suppliers. I know you're struggling. I know how hard it's been over the last few months with the global supply chain issues and that you've had to focus on those. But it's time to focus on this now because it's going to be such a big win for kids in maths classrooms. And then we move to division. If we have a division like 24 divided by 8, all we need to do is understand that we have a rectangle with 24 pops in. It's 8 along one side. Just going to have to pop that one back there. And we simply have to keep popping until we have used 24 pops. That's 16, 17, 18, 19, 20, 21, 22, 23, 24. There they're gone. And so the answer is 3. And this beautiful array model unites the idea that we have split 24 into 8 equal groups that each have 3 pops, or that we have counted groups of 8 and there were 3 groups. These two separate ideas of division that are so beautifully united when we think about arrays and rectangles. And of course, array also unites that calculation family. 3 times 8 is 24, 8 times 3 is 24, 24 divided by 3 is 8, and 24 divided by 8 is 3. It's all there in one beautiful array in your poppet. The next topic you can do brilliantly with poppets is factors, factor pairs, prime numbers, square numbers, and triangular numbers. So if you had a number like 24, if you had cubes or blocks, you could arrange those blocks into different rectangles to see the different factor pairs for 24. But of course, you can also do that with poppits, especially if you work in groups and have 2 or 3 side by side. You can set up competitions between the groups. Who can find the most rectangles with different shapes of rectangle with 24 pops in? And there you have your factor pairs. And of course, if you've only got a skinny rectangle that's 1 pop high, and that's the only rectangle that you can get for a number, you have a prime number. And you could also go back to this structure, overlay this, and pop out the 2 times table, except for 2, the 3 times table, except for 3, and so on. And you have a sieve of Eratosthenes, and you can see the remaining prime numbers. How much fun is that? And then, of course, you can also see your square numbers beautifully. What's 3 squared? What's 4 squared? And your triangular numbers. First triangular number, second triangular number, third, and so on. And I have found if children see triangular numbers as right-angled triangles, as they do here, rather than as triangles that go like that, they're laying much better foundations for understanding them when they're summating linear series and so on later. The next section of this video is all about shape. And what I'm going to suggest is that you simply name a shape and ask children to pop the corners of that shape to see if they truly understand what they're doing. And once they've got the basics of that, you can set it up as a game and a competition. Who can pop corners of a shape that's not congruent to anybody else's? So congruent is exactly the same shape. So by that I mean if you said kite, a child might pop, say, that. You see the top there, the 2 corners there, and a bottom down there. Of course, that is a kite. But if someone else had popped that one, that would be different. And somebody else might pop one using the poppet like this. Maybe like that. And that's also a kite. That goes from here down to here and up again. And suddenly they understand what the word congruent means. Yes. And of course, you can do work on symmetry. Who can create the best picture with a vertical line of symmetry? Vertical lines of symmetry are the easiest to start on, and of course you can immediately imagine how you can create beautiful pictures, and so will your children be able to do that as well. And then what about with a horizontal line of symmetry? Could you create mountains and a reflection in the lake to show your horizon? And we can also do 4-quadrant symmetry. And my final suggestion for this video is for data. If you're out in the street gathering some data, of course you could tally your data, and one child in the group might do that, but another might keep track of it on poppits as things pass by, and you have to keep a track on what's happened, and you've got a code for that. This is the magic of this bit of apparatus. Clearly this is going to come into classrooms, and it's going to be a wonderful tool to complement the other key tools that are already there, because it does so much and is much more versatile than any bit of maths apparatus I've previously seen. I promised I'd end with a little bit of behaviour advice. If you're teaching a whole class, you're going to need your behaviour strategies, because these are quite noisy actually when lots of children are doing them, and if you're talking, they need to not be doing that. So if you use a 1, 2, 3 strategy where 1 is hands up, you've got to make time to train them to understand that that means your poppits are down. You might want to use a number 2 to put their hands behind their back so they know that they are staying away from their poppits while you're talking, and you need to keep your instructions very short, or you need to get them to leave their poppits on their tables and come and sit on the carpet with you for longer bits of instruction and teaching. And in a whole classroom situation, I also recommend that you run into brain breaks with these. So you do a little activity and you tell everyone if you reach this target, you get a brain break to play with your poppits, and you stick to that. They're really good. They will be thinking and doing amazing maths while they're playing. But more importantly, children just do need brain breaks from their maths. If they're really engaged in learning, they get overloaded pretty quickly. Thank you so much for watching this video. If you have any comments, thoughts, suggestions, I'd love to hear them, either here on my YouTube channel, in my Facebook group, which is Expert Primary Maths Teaching, in my LinkedIn group, which is Math Education, Math Culture, or you can come and talk to me live on my YouTube channel every Sunday morning at 9 a.m. UK time. Please do subscribe to my channel so you can find it again. And if you want to see the full list of maths professional development videos, you can find those at authenticmaths.co.uk/videos. Hope this video has helped you love your maths teaching and get that incredible enjoyment out of seeing children come to life with their maths and really love it and thrive. Bye for now.